Hello, everybody. Thank you for joining our session today. Appreciate the fact that you chose us to start your week at reInvent, and I hope that what we're about to present will inspire you, and also look forward to all of you having a great week of learning ahead. For those of you also who are watching the replay, appreciate your interest, and thank you for watching as well. Today we're going to cover our journey to build a governance solution for Riot Games. We didn't realize at the time that we were setting off on a journey that would end on the stage at reInvent, but here we are. And today with me to present are Steve Fradley, Principal BI Analyst for Riot Games, and Rohan Jamadagni, Senior CDA for ProServe. I'm Randy James, Principal TAM for AWS Enterprise Support. And the other core person of our team is Daniel Martinez. He was our data architect. He's not here today to present in person, but was involved in building all of what we're about to present today. We're going to have some time at the end for questions, so feel free to take notes along the way, and we'll save those for the end and cover. So today we're going to go through an intro to Riot Games, talk about their growth as a company and as an organization on AWS. We'll give a little bit of background on where we were, why the growth, why the complexity of the data set, and what we needed for central governance. We'll talk about the design decisions that we made and some of the key steps we took along the way. How we built the solution, and how we found and solved the technical challenges. Our dashboards were a bunch of visuals. We will discuss how we surface best practices as actionable insights in those dashboards, and then we'll discuss where we're headed and some things that we're working on, and how you can do this at your own organization. With that, I'll hand it over to Steve to tell us a little bit about Riot Games and start off our journey.
Hey everyone, so as Randy said, my name's Steve Fradley. I work at Riot Games. I've been here now for about 7 years, I believe, and currently working on the governance team to do our cost optimization and efficiency utilization of our AWS cloud spend. So I'm here to tell you about Riot Games. First of all, how many of you played League of Legends? Okay, cool. That's more than I'd hoped for, so that's cool. How many of you seen Arcane? Awesome. Okay, for those who aren't familiar with Riot Games, we were founded in 2006, and from 2006 to 2009, we worked on League of Legends, and it was released in 2009 to worldwide acclaim. It's basically 2 teams of 5 battle to destroy the opposing team's nexus. League went on to become a global leader in esports. The annual League of Legends World Championship features qualified teams from 12 international leagues, and it's one of the most popular sporting and gaming events in the world. In 2019, we finally put the S in Riot Games. We released Teamfight Tactics, our auto battle chess. We released Wild Rift, mobile version of League of Legends. We released Legends of Runeterra, our digital card game. And finally, of course, Valorant, our first-person shooter. We also have Riot Forge, which gave developers access to Riot's IP. We can release games like Ruined King. And then we also expanded across music with KDA and True Damage, comic books such as Lux, board games, and Arcane, our Emmy Award-winning animated series. All this exponential growth over the last several years was the reason we're here today, as we need an in-depth understanding of our company spend and usage in AWS Cloud. So originally, we started with just 2 or 3 Amazon accounts and just 1 or 2 internal teams at Riot utilizing it. As cloud utilization increased over the following years, we had more teams using Amazon. And for that, we highlighted the limited solutions that we currently had. For example, Cost Explorer data, that's only on a per-account basis. And it didn't actually roll up or align with Riot's business needs and how we needed to report things. Recommendations from Cost Explorer were either at the all-encompassing organizational level or individual account level. So some of you here today, because you're probably also dealing with issues like we had on how to report, allocate, and attribute your AWS cloud spend. Riot's probably gone through the same pain points as you. Originally, the cost allocations was done by me just using an Excel sheet. It was limited to what we could do. It was performed after month close, and it provided a monthly point-in-time snapshot. Whilst this worked for our monthly accounting reporting needs, we also needed as close to real-time data as possible for our governance customers. Having this would enable both governance and the teams, our internal customers, being able to make faster decisions and choices on controlling our spend and purchasing savings plans, RIs, and other commitments. Our internal customers using this solution would also be able to self-service and obtain the data themselves. We tried commercial solutions, but unfortunately, while we had success, it wasn't sustainable as we experienced exponential growth. Right-sizing opportunities, security findings, et cetera, they were based off of, currently at the time, were based off of ad hoc observations in Trusted Advisor, Cost Explorer, and limited again to individual accounts.
So these ad hoc observations would come to us in enterprise support to get a deeper understanding of what was going on and how we would understand our spend. So our typical process for that is to prepare a management business review, where we pull a lot of data from Cost Explorer, make a bunch of CSVs, compile them into a PowerPoint presentation, and review them with Riot. This is a time-consuming process. For the more in-depth analysis, we would engage cloud econ teams, and they would do a similar process. Took lots of time to prepare. Generally was fired at the entirety of the organization, not at a particular business unit, and there was no way for it to really cover verticals that spanned across multiple AWS accounts easily. So we're talking about big data, big spreadsheets. Eventually that process falls over, and we're also limited on the amount of data that we could process at a time. We can only see a few months, and we needed to see beyond that to do some long-range planning. How many of you here are aware of the CUR, or the Cost and Usage Report? Raise your hand. All right, good amount. For those of you who aren't familiar, the CUR is the most granular presentation of the AWS bill. It's a file that you can configure in your billing console. It's delivered to S3, either as CSV or Parquet format. It's dropped into your payer account. And this automatically updates as AWS launches new services and features, which is a great thing because AWS, as you know, you'll see this week, we launch features all the time. But this also has potential for breaking things that you build downstream of that file. So it's something for us to be aware of. At 2019 reInvent, we launched savings plans, which were a big improvement in the customer experience for managing savings and are the next generation of what RIs were before. Savings plans also introduced a bunch of new columns to the CUR, some additional complexity and behavior that was different than RIs. And in order for us to effectively incorporate them into our governance reporting, we need to understand those.
So as Randy said, we had reInvent 2019, and this brought us to Arthur Basbaum, an Amazon Cloud Economics team member. He met with Derek DeFields, CTO of Riot Games, and presented a report. It provided recommendations for cost savings based on cloud economic benchmarks. It was a game changer. Although all this data was produced manually, and collated together, it showed the types of things that we at Riot were looking for. We wanted this report, but we wanted it automatically.
So this presentation had some insights, hourly level instance costs, some cloud benchmarks that it compared, and it showed us some important metrics, benchmarks, and KPIs that we might want to focus on. We used this to kick off a 2-day workshop with Riot, where we dug into how we could produce this reporting at scale, what Riot's business requirements were for reporting, and a way for Riot to be able to do this same type of reporting that took our team's manual effort and spreadsheeting to produce at Riot internally without involvement from folks in an automated fashion. So we used the understanding from the workshop along with the cost and usage report as the key ingredients to build a proof of concept version of this tool. The solution was developed as a joint collaboration between Riot, AWS ProServe, and enterprise support. We spent a lot of time working through initial data sets, building dashboards, and reviewing those on a weekly basis with Riot to refine what our core features and functionality would be for the tool.
So with that, we had to make some design decisions. So the primary was we wanted a unified dashboard where all our data and key performance indicators could be presented and filtered for our customers. It should have encompassed displaying all our spend, the ability to attribute it to different business roll-ups, how well we are doing with our cloud consumption, and additionally, folding in security findings in order to be able to mitigate any security risks. Internally at Riot, we report Amazon spend in 2 ways. One is to the singular owner of an Amazon account, regardless of tagging inside. The other looks at the accounting tags and attributes that cost based off of those, and spend is then totaled up from across multiple accounts for that one team. Governance helps both sides of this to be efficient by reporting on potential right-sizing needs and covering long-term spend with savings, by getting covered with savings commitments such as reserved instances and savings plans. We needed a solution to cater for the fact that Riot evolves and our teams change. We also needed historical data to get reprocessed by the current team setup so that it would help whatever newly formed team by already having access to instant historicals. They would then be able to see how well that team in particular would have performed in the past. Teams also have different ways of looking at their infrastructure. So we had to have the flexibility to support game environments, service environments, down to environment level, for example, and even as granular as possible that an individual team required. It meant we even got down to unit cost level per hour or per vCPU.
Yep. Thank you, Steve and Randy. Like Randy mentioned earlier, cost and usage report data is complicated. It is able to report cost in both unblended, which is cash-based accounting, as well as amortized, which is your accrual-based accounting. Let me take an example of a $1,200 savings plan purchase. So when it comes to cash-based accounting, your invoice will show that $1,200 on the date of purchase. When it comes to your accrual-based accounting, you essentially realize that spend that you actually did on the date of purchase throughout the duration of your purchase. So when it comes to accrual-based accounting or your amortized cost, you essentially show $100 being realized on a monthly basis for your purchase from the date of the purchase to the end date of the purchase. But CUR is again complicated where it is not able to amortize few of the costs when it comes to, say, your one-off purchases, your one-off credits, your reserve instance purchases, your unused portion of your reserve instance or savings plan cost. We wanted, like what happens with that is when you see your trend data, you'll see a spike for, say, on the date of the purchase, or for when it comes to reserve instances, you essentially just amortize on the top of the month, and then it is consumed throughout the month. So you'll see a blip or spike on your cost data or trend data, which actually does not help teams in trying to sort of like do trend analysis and predict for how their spend will look like, how their usage will look like for the future. So we came to a design decision is we will amortize all the costs, even the costs that will happen on a monthly basis or yearly basis to a granularity of daily basis. So we started amortizing the credits, discounts, reserve instance purchases, and unused portion of your reserve instances as well. The other design decision we made was the dashboard should be very intuitive. It should be very easy to understand for the engineering teams. They should be able to provide guidance at a resource level and reasons for cost fluctuation and model coverage changes. By that, I mean is whenever, say, coverage changes change from, say, 70% to 80%, I, as a team owner or team member, should be able to predict what should be my annual spend or monthly spend based on that coverage change, say, when I move from 70% to 80%. And also be able to assist in long-term purchasing and commitment decisions. We wanted the dashboard or our solution to be able to detect any deviations or fluctuations in the spend or the coverage changes, and be able to take action before the billing cycle is completed and understand the day-to-day variations. And last, we wanted the data to have access control. Essentially, each of the team members or the team owners to have access only to the data that they are owning or the teams that they are owning, not the entire organization-wide data. To do that, we actually went to the solutioning portion of our engine, and we started consuming more AWS services. To get into details, Randy will talk.
Yep. So although we started off with the CUR, there's a lot of services that AWS has that emit best practices events, things like Trusted Advisor, Compute Optimizer, CloudWatch, Cost Explorer, and various APIs, services like Storage Lens. So we wanted to come up with a model that would be able to support these, not just use the cost and usage report. So we surfaced the best practices that Riot cared about using these tools. We collected them with a pipeline, and we wanted to make sure that not only were we reporting what was spent or what was saved, but why was it spent or saved. We wanted to highlight where there were opportunities for improvement across financial, security, and tech. And we needed that modular approach to be able to incorporate not only current services, but the ability for future services that would be launched, and even to bring in third-party or internal tooling.
So with that, we had to make some design decisions and make some changes to our solutioning approach. So we decided to solution our engine based on data lake approach. So we took all these additional data sources. We built it based on a data lake approach. And then we'll go into the details of how we collected all that information, stored it, enriched it, and finally presented it in a unified dashboard consuming all these different data sources. So the inputs for our solution are some AWS services, some Riot-specific data sources, and some third-party data sources. We collected all of that information either natively delivered when it comes to cost and usage report in the main pair account, which we replicated into the reporting account. The reason for that is we did not want the end users to have access to the main pair account, and we wanted to have a centralized solution for all the unified data sets and data sources that we have. When it comes to storing the data, we followed that same data lake approach, where we would partition all of the data sources into their own prefixes and partition them based on source and date time. We would then enrich all of these different data sources based on Riot's organization mapping that Stu talked about earlier. And when it comes to data sources which were not cost and usage related, we enrich all of those data sources with not only the business mapping, but also the cost, the true cost that would be realized. We would then aggregate all of these different data sources. We will allocate the cost per teams based on their usage patterns. By that, what I mean is, let's take an example of 10 different teams. And let's say on a monthly basis, your total spend is $1 million. And say team A actually spends 10% or is responsible for 10% of that spend. So when it comes to amortizing of the one-time credits, essentially like 10% of your credits should go to team A based on your usage patterns. We did all of that logic through our data pipelines. Finally, we aggregated all of these data sources and unified them, combined them into QuickSight, and made them available for data set analysis and visualization. I'll dive into the details of the architecture now. Our architecture is based on 3 main groupings. Part 1 is where we collect the information in raw format. Some of the data sources, like cost and usage report, are replicated from your main pair account. And some of the data sources are not available in an aggregated format. Like when it comes to data sources like Trusted Advisor or Compute Optimizer, what we did was created global roles, and Lambda function would go into each of your linked accounts and pull data from each of those linked accounts and dump it into our S3 bucket. What the S3 bucket, we kept the S3 bucket in the raw format, essentially as the first landing place. With that, we were able to not only see the data in the raw format, but when it comes to data quality checks, we were able to refer back the same data if we needed to do data quality checks. The second place is where we will go into the enrichment of that data. Each of those data sources, we use Glue jobs and PySpark to enrich that data based on Riot's rollups, business rollups, as well as the reallocation of the cost or amortization of that cost. We would then persist that data into the process bucket. And on top of those persisted data, we will build, again, catalog that data and build Athena views. Those Athena views would feed into our QuickSight as data sources. So for QuickSight, Athena was the data source, and we feed the views that were persisted from Glue using the Athena queries into the QuickSight. We use SNS for notification, and the aggregated data was then published into the reporting bucket for any future requirements, or if we needed something for downstream processing again. So with that, we'll get into how we started surfacing few of the key insights on our dashboard and how our dashboard, single unified dashboard approach looks like.
So we built a few dashboards. Initially, we had almost a kitchen sink approach where we reported on a lot of things. This data lake was great. We had this foundation where we could find interesting things, not just the stuff that we would see in Cost Explorer if we had access to the payer account, but we were able to see things like instance counts, vCPU counts. So we were able to get cost levels for each, and we were able to slice those across the business. So we, over time, with our weekly working sessions with Riot, we distilled the dashboard into 2 different experiences for different personas at Riot. We had the executive dashboard where we would surface finance and governance info across the org, kind of at an overview level that would show key performance metrics like on-demand rate versus Riot savings and Riot rate, effective savings rate, total percentage running current versus previous generation instances, status of moving from GP2 to GP3, which is a engineering effort. So that's the executive dashboard. And then the executive dashboard had quick site URL actions that linked it to TechOps dashboard. And this is a dashboard for engineers and operations teams that go down to the resource and ARN level. So you click on an action in the executive dashboard, goes to the TechOps dashboard and shows you these are the exact resources that will be impacted by this particular action item. We focus the data at the team level. It's bound to Active Directory behind the scenes, implements row-level security. So when you drop into the dashboard as an engineer, it's a member of a team. You have access and visibility to your data set, your workloads, and the rest of the organizational workloads are hidden, which is also another nice benefit of not having to provide everyone central access to a payer account in order to see and study their spend. These dashboards are used as part of a regular review process called the Riot Act. This is a monthly review session with Riot's governance and finance teams for each team within Riot. So this is the repeatability factor of that presentation that previously was manual. And during each of those reviews, finance, tech, and security recommendations are called out as attack moves for teams and recommended action items. So we needed it to be simple. Dashboards can get complicated really quickly, as we learned through our first phases of the POC. And we arrived at green is good, reduce the red philosophy, which is simple messaging, act on the red. So as an example, this visual at the top shows 3 different types of spend. We have ineligible spend, covered spend, and uncovered spend. The red, uncovered spend, is something that you could purchase an RI or a savings plan to cover and generate some savings from that. The green covered spend is how much coverage your team has, and the gray ineligible spend are spend that cannot directly be actioned upon by a purchasing from your team. So for example, data transfer or services that don't have RI or SP support. So there are 9 services that support RIs or savings plans, and we showcase those in the visuals, and we also use the similar green is good, reduce the red philosophy to apply to our other recommendations like right sizing. These team level actions were surfaced as part of the Riot Act reviews on a regular basis.
So this is where it starts to get interesting, and we started deviating from some of the standards that are mentioned on the Cost Explorer. When it comes to Cost Explorer, your reserve instances are covered using your usage, and your savings plan is covered based on your dollar spent. We wanted the teams to have a single visual that represents all of their total opportunity size based on what can be covered, either through RI, SP, or spot. We defined the combination of that 3 as our coverage spend percentage. With that, what happened was whenever a team members or team looks at their spend, they are able to track how their coverage percentage looks like and what is the true opportunity size. To that, we use dollar as a unifier between reserve instances, savings plan, and your spot coverages.
So we've got a bunch of visuals for governance's internal teams to use, consume, and review, but also we needed reports for our governance team itself, and that brings us to the visual there on the bottom right. Now, I'm a total nerd, and this is, to me, one of the coolest visuals we've got in this system. Basically, it shows us the sweet spot of where we'll be with coverage. Works is that the 100% line is plotted, which will be if all of our EC2 is covered, and then on top of that, it overlays what Riot's current coverage is. If it's below 100%, it then uses math to calculate above the 100% a mathematical equivalent. This will then help us understand the break-even point on whether to take additional EC2 commitments versus letting something remain at just on-demand pricing. Although it seemed counterintuitive, this actually mathematically proved out we could still stay within our coverage targets even though we're actually overcommitting on EC2 commitments. This enables us to provide day zero coverage, so when a future project is ramped up, that additional spend will then immediately become under the realms of a savings plan and will get the immediate benefits.
Yeah. So to get into the details of how we built this, we came up with something called as eligible usage. What it essentially is your combined usage of your covered spend as well as your opportunity that can be covered. We then got to the granular details of what is my hourly dollar value to cover savings plan usage and what is my hourly dollar value to cover on-demand prices. So with that, we then got to the place where if we have to model for, let's say, 100%, whatever is your unit hourly cost, you multiply your total usage by your hourly savings plan or reserve instance pricing. Same way, if we have to model for, let's say, 80% coverage and 20% on-demand pricing, we will multiply the 80% of the usage by the hourly dollar value of your savings plan purchases or reserve instance purchases, and 20% would be multiplied by your hourly usage dollar value for on-demand pricing. With that, we were able to model essentially what would be my spend looking like, let's say if I have 80% covered, and do actually a mirror equivalent of that, what it in terms of dollar value means if I go, say, beyond 100%. And the use of going beyond 100%, like Stu mentioned, is whenever there are workload changes or new launches, we are able to cover those utilization or usage from day one itself.
So with all this data to hand, we're able to set coverage targets for governance teams and for Riot as a whole. We report on when these targets are even exceeded, calling out additional savings beyond what was aimed for, both in terms of dollars and additional percentage points. Additionally, we can also show where the team's savings come from. For example, which sub-team, which service, and even down to which resource ID levels gave them the most discount.
Yeah, and this is where we start to actually incorporate our unified data set approach, where we start enriching the data set like other data sources with Riot's business logic, as well as the true cost value from cost and usage report to provide like true opportunity sizes. So we took the recommendations from Cost Explorer. When it comes to like Cost Explorer actually tells you what is the reserve instance or savings plan that you can actually purchase. We took that recommendation, and then we predicted that against what is our upcoming reserve instance or savings plan that are about to expire, say, in next 30, 60, or 90 days. We then went further to that, is based on that recommendation, we came to an opportunity size based on what are my instance size or instance types that would be covered, what would be the essential resource IDs that would be covered by the recommended reserve instance or savings plan. Like each of our visuals on our dashboard are able to be controlled by a set number of filters. So you can get into the details of which particular team's coverage is being covered by that recommended reserve instance or savings plan, which particular resources, and which particular environment those resources belong to. With that, the teams can make an informed decision of this particular resource ID is recommended, or this particular instance type is recommended for me to be covered by Cost Explorer, to be covered by reserve instance or savings plan. Does this particular resource ID belong to my production workload or development workload? And do I need to actually cover that based on reserve instance or savings plan, or is there an opportunity to right size that particular instance? And then if I have to right size, or I can come up with policies to, let's say, if it belongs to a development environment, I can shut down that particular resource ID on weekends. The other thing that we did was showed a commitment which is being utilized in terms of who is purchasing that particular commitment and who is benefiting from that purchase. This can help with identifying the true commitment value needed by each team, and also help with chargebacks if needed. Further to that, we started showcasing the optimal recommendation and optimization recommendations for each of the resource IDs. We pulled that data from Compute Optimizer, used the same visual treatment that we have across the dashboard of green is good, red is the red. With that, we are able to showcase each of the resource ID that are, say, either over provision or underutilized. And then with that, we are not able to, by enriching our data set and having a unified data set approach, we are not only able to showcase which particular resource ID is over-provisioned, but tell the reason of why that particular resource ID is over-provisioned. Like for instance, in this particular case, we are able to showcase that this particular resource ID is over-provisioned because CPU is over-provisioned, or memory is over-provisioned, or EBS throughput is over-provisioned. And then on top of that, we overlaid that information, pulling in data from CloudWatch metrics for that particular resource ID to showcase why that particular resource ID is over-provisioned in terms of CPU capacity, to showcase what is my CPU utilization looking like in, say, past 15 days, based on what my max, minimum, and average utilization looks like. For instance, in this case, my CPU max utilization or average utilization never went above 3%. So again, like going back to the same analogy, I as a team member can then refer back if that particular resource ID is optimal for right sizing, or if not, whether I can either shut down that particular resource ID or right size that. We showcase that opportunity across all of the resources that belong to a particular team. So that way I can see an audit of all my resources within a particular team. Of those, all the resources, which particular resources are right sized, which are over provisioned, and which are recommended for right sizing. And on top of that, we are able to show the true savings opportunity in terms of write cost, not on-demand cost, for those resource IDs if they are fine-tuned. We did the similar approach for right sizing for all other services as well. When it comes to RDS, idle instances, S3 storage buckets, to move from one storage tier to other storage tier, Redshift clusters that are underutilized, all of those. Additionally, we wanted the teams to have an ability to cover their coverages, and if there are actually any deviations in the coverages or spend, be alerted in near real time. Usually, AWS budget is able to showcase you or alert you whenever there is a change in your budget or spend, and whenever threshold is breached. But that does not tell you why that particular threshold was breached. We wanted to have that enrichment of the data. To do that, we came up with two-way approach. One is enrich the data for budgets and define dynamic budgeting for each of the teams based on their past 45 days average spend. What we did was use that DynamoDB table that you see on the leftmost side, or the rightmost side, where you're looking from, to actually host the business logic. Whenever there is a deviation in the business logic or new addition is done to the business logic, we'll use this Lambda function to add it to the SQS queue, which will trigger an event bridge. That triggers the second Lambda function that is responsible for defining daily budgets for each of the teams. The budgets actually pull in for each of the organizations, like each of the linked accounts within the organization, and trigger based on the threshold being breached and creates an SNS alert. We take that SNS alert and use this Lambda function to pull the real-time data from Cost Explorer to enrich the budgets and send a SES email to the teams on why their budget is being breached. The alert looks something similar to this. For those of you who are in the back, if you're not able to read, but like what we showcase is essentially which particular team's alert, which particular team actually breached their threshold, and provide the reason for why that particular threshold was breached in terms of which particular accounts within that team is responsible for threshold being breached, and within that account, which particular services are responsible for the threshold being breached. And for each of those accounts and each of those services, we showcase the spend for past 15 days. To showcase how the trend is looking, essentially, is that a one-time blip, or is it a trend that needs to be accounted for, and the team needs to work with the governance or Cloud Center of Excellence? We did the similar approach for coverage percentages as well. So whenever there is a deviation in the coverage percentages, we would notify the teams, and that way they can work with the Cloud Center of Excellence teams or governance teams to actually plan and account for any new upcoming workload or launches. Yep, sorry.
So as you can see, like over time, we became more real time with the approach. It wasn't just about a monthly review. It was daily, and then 2-day delay for that data to go through that ETL pipeline. We wanted to also get more atomic with what we could see. So we started looking at how could we look at app-level utilization for things like pods, and we decided to incorporate KubeCost into it, and CloudWatch and Compute Optimizer leveraged on top of the organizational tagging to show a particular workload regardless of what node it's running on, whereas previously we would only see a node as a resource ID. This enabled us to get further down into the workload and understand the efficiencies there. We took the same approach with security tooling, integrating tools like Lacework Security Hub to build us some scorecards that were aligned with CIS benchmarks and tracked all of the core security effects that needed to be applied to all the teams across the org. So we're still on the journey. We have a roadmap ahead to build a lot of things. This is a preview of some of the stuff that we're working on over the coming months. One of the things that we're looking to is to improve the RISP process by having an actionable item within the dashboard. Team can click on it, action, and that triggers a approval workflow on the back end, and you can track the process end to end and show what resources were covered from that at the end of the purchase. We're looking to further enrich unit economics and understand and visualize costs at per player, per game levels, and be able to report those as dashboards and make sure that we have metrics not only across compute for game servers, but across other services that are platform services and support multiple games. We're looking to integrate service health monitoring, service limits, and just general operational state details to help teams get ahead of limit increases, make sure that accounts are configured the way that we expect them to be ahead of time, and review those as part of the Riot Act process. We're improving our data quality and delivery mechanisms by adding data ops with lower environments, including the ability to capture visuals that are created in the QuickSight tool and promote them up into the dashboards for executive or tech ops. QuickSight has some features that we have yet to explore, including QuickSight Q, which is an AI ML-driven service that uses natural language. You ask it a question, it spits out an insight, so we're looking to incorporate that. And we also want to continue to add new features to our dashboards as QuickSight adds new features and support for new things, bigger data sets, new inputs, and additional insights that are surfaced from the data lake.
So with all that said, we've got a few key takeaways for you. Your cloud governance approach should be tailored to your own organization. You need to understand what's driving your cost and usage. You should establish a foundation for reporting cost and usage with tagging. That certainly helped us at Riot. Good tagging was able to get us to aggregate and then granularize and split all of our data. You should align your approach with teams, apps, or whatever lines of business that your company is division into to be able to set targets and provide guidance. You should regularly evaluate whatever savings you have from any reserved instances and savings plans to make sure they're still aligned with whatever the plans you had for coverage, your goals. You should also have right-size reporting available at team, app, and line level, again, to align with your business. Near real-time alerting enabled us to have faster insights and be more actionable instead of waiting a few weeks as we used to do in the past. Keep your KPIs and goals simple. For example, do we want to maintain 80% of EC2 coverage? And then also simple mantras like green is good, reduce the red. That helps our internal customers understand concepts when they look at the visuals in QuickSight.
Thank you, everyone. Appreciate you all attending our presentation today, and special thanks to all the Rioters and Amazonians who've been involved in this journey, and special thanks to Arthur and Derek for taking that meeting in 2019 to kick this all off.
Okay. All right. Well, thank you so much, everyone,
Thank you, everyone, for coming.
Yeah.